Welcome to my Commodore 64 Games Memories. This is where I look at old games and some of the technical details behind them. Let's get into it. Today we have Tilt, published in 1990 by Codemasters, coded by Stephen Walters, and the musician was Steve Barrett. This game was suggested by one of my YouTube commenters to find out how it's rendering this 3D view. So let's have a look. So yes, if you like these kind of technical deep dive videos, then please do consider liking or subscribing to this channel or sending me a super thanks. They are all always very much appreciated. There doesn't seem to be a disk version of this game, and because I want to have a look at this in C64 Debug GUI, which doesn't load tape files, I need to try and extract the game from the original tape image. So I'm just running through the tape, auto running turbo loading code here. In Vice, we can switch on the warp mode, which will let it load quicker. But I'm just basically going through the same kind of thing that I've done before many times in previous videos, where I'm just going through the code to try and disassemble and reverse engineer the loader and then trap where the game starts, just before where the game starts running, so then I can save all of the RAM and then compress it and then load it in C64 Debug GUI. While the title screen or the loading screen is displaying, let's use the mmzap command and then the mmshow command to show the typical memory execution range of this loader. And it's basically not running any code beyond 3EE. So let's do a ranged breakpoint from 3EF all the way up to E000. I noticed that the loader code was actually using a couple of kernel routines for increasing, I think it was AE and AF pointers, 0-page memory locations, and then doing a compare to see if the load had finished. So it was reusing some routines in the kernel. So that's why we don't have a range breakpoint all the way at the end of kernel. Let's see when this triggers. Here we are, the range breakpoint has triggered. We've got back into code at 460, so there's a little bit of CPU history there, but basically it looks like the turbo loader has finished and it's starting to run some code, and I can see immediately at 465 there's a little jump with 80D just after the breakpoint. If we use the M command in the monitor window, we can see that we've got some basic code left, which does a whole bunch of load with file names, 8,1. So it looks like that this was an original disk version and then mastered to tape. But basically the jump to 80D is going to be doing this sys2061 basically. And let's have a little look at what that code does at 80D. It's probably just going to be doing some initialization. So I think what we can do is that we can just save the memory at this point and then compress it and then use the compressor to jump into 80D. I don't think we need to do any other setup code. Let's use the monitor window to just double check the code at 80D. Yes, it sets the interrupts, restores the processor port, which is location 01 in hex, initializes the screen and VIC and everything else in the border and screen colors. So yeah, it looks like good initialization code there. We'll just tell the compression tool to execute from 80D. So let's save all of the memory. That's why we did a bank RAM first of all, just to make sure that we get the memory. We'll note down the start address 80D in the file name, just so that we don't forget what it is. And we'll just save the whole of RAM from 200 to FFFF, ignoring 0-page because the decompressor wants to run its code from lower down in 0-page. So we'll just use my LZMPI compression tool to give this whole great big chunk of memory an executable program file header that can be just run in C64 Debug GUI. This is very hopefully quick and simple hack and pack, if you like, although there's not really any hacking involved. It's just putting a breakpoint and then saving all the RAM. It's very simple. So if we just run this in the new emulator window now, just by running the t.prg file, and there we go, we get straight into the title screen with the animating tilt logo. And then we have this rather wonderful tilting level thing. So Let's close these other emulation windows. Let's open that now in C64 Debug GUI. And then let's have a look where the sprites are, first of all. That's what we need to find out first, I think. C64 Debug GUI is really good for looking at where sprites are on the screen. We can immediately see from this view, actually, that the Codemasters logo, because it's got those red boxes around it, we can immediately see that we've got sprites with the Codemasters logo on top of, okay, so the character set view on the top left-hand corner there is showing dynamically updated characters. Okay, and that's almost certainly for that tilt logo, and look at that. Isn't that fantastic? Well, we've got a whole bunch of collection of sprites in the bottom left. We've got a sprite for the hole, which is the target in the level there. And then it's looping back to the attract mode. The joystick control in this emulator seems to enable both joysticks at the same time sometimes, I think. Anyway, it seems to be not starting the level properly, but that's okay. I'm not really interested in starting the level. I just want to see what the sprites are doing. And we can see that we just have this collection of sprites. Now, the collection of sprites, if you notice, look, they're moving at different rates, which kind of like creates this like 3D ball with a stick coming out of it with its shadow. The hole in the background there is just a sprite showing different animation frames. Let's use the Vic debug mode to look at this tilting effect screen. We can see that it's using text mode, high-res text mode for the scrolling message, but multicolor text mode for the middle part of the screen there. We can see actually that there's some X scroll and Y scroll updates going on for this main part of the screen, or the Y scroll updates anyway, and that's when it's tilting the screen up and down. That's interesting to note, but it's using a static, well, it's using the same character set, but updating it dynamically. So let's have a look in ICU 64. Here we are in ICU 64 with our graphics map views and sprite views and the memory view open. So we notice that, first of all, that the text screen, if we are viewing the text screen with standard ROM character set, we can notice actually that the edges, well, so when it's tilting vertically, the edges of the character set for the vertical edges of the T, for example, the vertical edges of the L are definitely definitely sending characters to the screen or updating characters on the screen, and we can see that we've got those dynamic characters in the character set data also being updated. So it very much looks like, doesn't it, that a combination of these effects, characters being updated on the screen and also dynamic characters, used in combination are generating this tilting effect. But let's have a little look at this in more detail. So so I'm not very good at this game, so I'm probably not going to attempt to play this game, I don't think, but we can tilt the level actually when it's in this level starting mode. So let's just tilt the level and let's have a look. So we can see from the it's not really possible to stop the level. So yeah, this is very, very difficult to control. Obviously I'm far too old and my reactions are not very good these days. Anyway, we can look at the level before we actually start playing the game by moving the joystick. I see. The joystick fire button opens and closes the doors. Okay, that's interesting to note. But yeah, we can have a look at the level by moving the joystick before we actually start playing the game, which is useful for us. Yeah, you see, I'm really terrible at this. Yeah, okay, I'm not going to be able to play through this game at all. Okay. So let's note from this zoomed in graphics map view here that what we have. Well, actually, just running quickly through memory, we've got levels, what looks like the current level, perhaps. And also we have other screens. So maybe there's 4 levels in this game. 1, 2, 3, and 4. They look difficult, don't they? Even viewing them in the standard ROM character set, they look difficult. But anyway, this is the screen that's being rendered. We can get rid of that. We can use, we can just run through the sprite data for the graphics maps. We just seem to have most of the game sprites in the first bank, Bank 0. And then the other bank has the Codemasters logo. Well, actually, look, the game still has the loading screen up at the top of RAM as well in the last Vic bank. So when we generated the compressed PRG, we didn't actually need to save all the way up until the end of memory. Anyway, so we can see here, look, if I tilt up and down, mostly the border around the middle, around the edge of the screen is updating, but the characters in the middle are not. There's no screen updates for the characters going on in the middle portion of the display. So this game generates what looks like the up-down perspective effect by updating its dynamic characters. Look, you can see that the character sets are kind of like scrolling around and showing different amounts of characters. If I pick up this @ character and then paint over the middle here, give it a nice solid box, and then move it around, you can see that the @ characters are smoothly scrolling up and down and left and right in the C64 view. In the debug graphics map view, the characters are not scrolling, of course, because the debug graphics map view doesn't include the smooth scroll X and Y registers. So that's interesting to note, is that if you look at the debug graphics map view and you look at the real C64 output side by side, you can see how the dynamic character set updates are creating the shadow effects. If we look at this in more detail in the C64 debug GUI, we can see that as I move the screen up and down and tilt the background up, down, left and right, that the X scroll and the Y scroll registers are updating. And this is what I think gives and we can turn on the bad lines and we can see where the bad lines are just to really validate this. And you can see that the bad lines are moving around as well as the vertical scrolls up and down. So the vertical scroll and the horizontal pixel level scrolls, the hardware scrolls, are moving what is apparently close to the camera. In other words, the playfield area, which is the closest point to the camera, which is generating that rather nice swinging effect. And also it updates the color position for the doors and stuff and things like that on the screen as well. So everything seems to move correctly. So the apparent swing is for the stuff that's in front, the closest to the camera point. And then all of the shadows and everything are using, well, the shadows are mostly using dynamic character set updates to create the borders around the foreground. And then we have the character set, the characters on the screen being updated for the frame around the playfield, the area, just the frame around it. So this is a combination of 3 different effects, which generates quite a convincing 3D effect, doesn't it? If you compare the debug graphics map view, which doesn't include the pixel scroll registers, with the Commodore 64 view, you can see how this layered effect works together so without the horizontal and vertical pixel scroll, the effect is still pretty good, but you don't get this kind of like popping out of the screen swinging effect of the foreground. But with the pixel hardware scroll registers updated on the real C64 screen, it accentuates the popping out effect of the foreground, which is great. The popping out effect on the foreground as well seems to be accentuated by the border of the screen. Let's see if we can get rid of the code that updates the border of the playable area. to show what that looks like without it on the Commodore 64. So what we need to do first is that we need to find out what is updating the screen. The border area, you put the characters of the screen. So we need to find out what's updating this area. So we'll just put a ranged breakpoint and we'll comment out all of that code and we'll see what happens. Or we'll try and find the code anyway. So bringing up the monitor debug window, and we'll put a ranged watch point store for that range of memory. Whoops, I did a typo. That should be watch 400 to say 500 for the top of the screen. First 256 characters up at the top of the screen. We seem to have this code here. This disassembly seems to be inside a little subroutine. So let's remove the ranged watch point, and then we can just trace back out to the RTS, I think, and then see where this calling routine is being called from. So we'll delete all of the watch points. We'll just hop out. And there we go. We've got this JSR to 1744. That seems to do at least some of the updates. Just updating the ranged watch store point there for 400 to 7F7 to catch all of the code, hopefully, which updates the rest of the screen area, especially the parts of the screen down at the bottom. So we fill all of those JSRs with EA from 635B to 6372. Get rid of all of that code, and then hopefully that's the last ones. Took a couple of iterations to get all of them figured out. But yeah, now I can move the play field around, I can tilt it around, but the border around the side of the screen is now not updating. So what we can do is that we can fill the border around the edge of the play field with the @ character. There we go. Just doing it by hand in the graphics map view. And there we go. Now if I move or tilt the play field around now, you can see that without the border area around generating that apparent perspective effect around the border area of the playfield, the tilt effect again looks different, doesn't it, on the real 64? So if we use the characters now in the debug graphics map view for the text screen, you can see now how without the perspective border effect, the tilt effect looks even less of a tilty effect now, and by ignoring the hardware scroll register values as well in the debug graphics map view, we can see now how very obviously that the dynamic character set updates look very different. And now with the perspective border effect now back in again, we can see how the perspective border effect accentuates the tilting effect for the level. What's interesting to note now is that, look, the doors for the bottom part of the level aren't there. Okay, I have an idea. Let's see if we can cheat in this game by removing some of the difficult parts of the level. We can use the debug graphics map editor window here to actually edit the characters. And then we can see if we can go through those doors. Yes, look, the doors, because they're not there in the level, we can just run straight through them. No problem at all. And then if I press fire, the doors come back again. Okay. So I think what we can do is that we can just edit the whole level. We'll just, get rid of all the walls, right? Let's see what happens if we just get rid of the walls. And then play the level that way. So the level is looking a lot easier now, isn't it? It's relatively easy, but the ball is still quite difficult to control, my word. Okay, there we go. And yes, here we go. That's what it looks like when you complete the level. The level nods at you. Oh look, some cool little sprite wheels are coming up, and then okay, that's a really cool, nice effect. I do love that, actually. That's a really nice way of introducing the next playfield. And maybe we'll do the same. Let's make the level a lot easier. Yeah. I'm sorry, original coder. I've just destroyed the difficulty in your game by using modern tools. Okay, so there we go. completed the second level. Thank you for nodding at me in that approving manner. Alright, so yeah, I do like that level transition. I think the level transition is cool. So the tilt logo effect for the title screen is obviously reusing the same mechanism for updating the apparent perspective of the vertical portions. If I paint in some at characters, which are the solid characters, you can see how they move up and down on the title screen on the C64 view, but on the debug graphics map text screen view, they don't move up and down. So you can see how they update to generate that apparent perspective effect. What is actually interesting to note as well is that the little scrolling message down at the bottom is jumping up and down in the debug text screen view, and that tells me that the split between the logo and the scrolling character set for the message is actually not stabilized. Oh wow, I didn't realize before, but the game actually goes through like a playable example of how to complete a level, and look, it's got a sprite-based joystick display up at the top showing you when you press fire and which direction you press to actually complete the level. Wow, that's great, isn't it? Okay, I suppose this game was deemed quite difficult, and so they put in like a playable demo thing. Anyway, so if we continue painting the solid characters over the title screen, we can definitely see how the effect breaks down. And if we paint in those equals characters in the debug graphics map view, we can see how they basically render the portion of the shadows. And then if I paint in those A characters, we can see how the bottom edge how the bottom edge of or the top edge of the solid characters are introduced and removed from the dynamic character set updates as well. So if we use the debug editor here to edit the screen, we can see how the effect breaks down, but we can see how the effect actually updates only certain characters on the screen. So yeah, this tilting effect is basically a great example of how you update the minimum amount of memory on the Commodore 64 to generate what looks like a really quite complex apparent effect, but it's actually, not complex. It's not updating. It's a complex method, but it's not updating that amount, a huge amount of memory. Actually, really, it's not doing a full 3D rendered view. Look, if I paint in solid characters in the demo self-playing demo view, it aborts the self-playing demo. Interesting. But yeah, anyway, this scrolling message, look, it jumps up and down, and this is jumping up and down as the Y scroll pixel hardware scroll registers are updated, or register is updated. And this tells me that the split between the horizontal view scrolling message and the middle part of the screen is actually not stabilized. And if you don't stabilize it properly, then you get this jumping up and down of where the band line appears, and the band line sometimes pulls in an extra row of graphical data, or not. It's just a side effect of how you update the vertical scroll register and the timing within the raster line. So there we go. I think that covers everything in this game that is really worth looking at. The tilt effect is just a combination of 3 different layers of those effects that we just looked at previously. If you like these kind of videos, then please do consider liking or subscribing to this channel, and I hope to catch you around next time. Have a great day, evening or night, wherever you are.